So because we don't actually know the function that is the inverse of b to the x, it can be challenging to solve exponential equations in general at this point. Now, I say in general because in a special case, it's actually pretty easy. So here's a kind of equation that we totally know how to solve. We can actually solve this one just by trial and error, right? 125, I think that's some power of x, right? 5 to the first, that's 5. 5 to the second, that's 25. 5 to the third, that's 125. So this says 5 to the x is 5 to the third. And so we know that x equals 3 is a solution, right? Because if we plug in 3 for x, that equation is true. And because the exponential is 1 to 1, we know that it's the only solution. So we get just x equals 3 is the only solution to that equation. We can use this same method anytime we can write something that looks like this. In other words, as long as we can rewrite each side of the equation with the same base, then we're good to go. We'd like each side of our equation to be powers of the same thing. So here's an example. 1/5, we know that 1/5 is 5 to the negative 1. So we think, okay, powers of 5 are what we're dealing with here. Can we write 25 as 5 to the something? Well, yeah, 25 is 5 squared. Coming up with those numbers requires some trial and error. We just need to guess what numbers we can take powers of on both sides. But having done that, we can now rewrite each side of this equation in terms of 5. So the left-hand side, I'm going to replace 1/5 with 5 to the negative 1. On the right-hand side, I'm going to replace 25 with 5 to the second. Okay, and now I've got these parentheses that I want to get rid of. And to use that, I'm going to use the power of a power rule, right? When we take a power of a power, we multiply the exponents. So on the left, we have 5 to the power negative 1 times x minus 5. On the right, we have 5 to the power 2 times 3x minus 1. And now this next step, I can either think of myself as applying the inverse, or I can just think that I'm using the fact that the exponential is 1 to 1. If the powers are equal, the exponents must be equal. So either way, I have that negative x minus 5 is the same as 2 times 3x minus 1. Okay, now that's a linear equation. I totally know how to solve that. I'll just distribute. On the left, I'll have negative x plus 5. On the right, I'll have 6x minus 2. Get all the x terms on the left, all the constants on the right. I've got negative 7x equals negative 7. Divide both sides by negative 7, and I get x equals 1. And I can check that. If I take 1/5 to the 1 minus 5, that's 1/5 to the negative 4. I could do that on my calculator, or I could say that's 5 to the 4th. Either way, that's 625. If I take 25 to the 3 times 1 minus 1, that's 25 squared. That's 625 again. So we get the same thing. That really is a solution. because the exponential is 1 to 1, we know that there's only one solution. So as long as we can rewrite both sides with the same base, we can use this technique. We can also detect some cases where there's not a solution at all. In particular, the range of an exponential function is not all real numbers. So sometimes we have no solution. So for example, if we meet the equation 4 to the x equals -4, that has no solution because 4 to the x is positive for every x. This is the same thing that we did with the absolute value equations and the quadratic equations, just put in more function-related terms. Since the range is not all real numbers, if we set an exponential function equal to something that's not in its range, the equation has no solution.